Hello, everybody. I wish I had hold music for while you were holding. We're going to get rolling right here. My name is Jorn. I'm one of the solution architects. I focus generally on security here at SUSE. In fact, I focus on Kubernetes security. So I'm going to do a little live demo towards the end of it. So please stay tuned for that because there's nothing like a live demo where you can say, haha, I want to watch the nerd trip. Also with me is Jamie. You probably got an email or several from her. Without Jamie, none of this would happen. So thank you, Jamie. I'm even going to put Jamie on the spot. She's like, please don't. Jamie, will the attendees be getting the recording from this after it's done? Because we know people will ask that question.
Yes, they will be receiving it in a follow-up email, most likely tomorrow morning or tomorrow afternoon.
Perfect. That's usually standard operating procedure. So I was kind of expecting a yes with that rather than a why did you say that, Jorn? By the way, yep, my name is Jorn, and I've been in the industry. Here's my, why you should trust me. I've been in the industry in IT for about 31, 32 years. I'm old enough to not be able to remember time anymore. At various companies, service providers, I've been focused on Kubernetes security for about the last 4.5 years. Thank you for being here. I really mean that. I'm getting paid to be here. Jamie's getting paid to be here. The rest of you are paying to be here. And I want to make sure that you come out of this and in the next 55 minutes, you've left with something that's improved your life and you haven't wasted any time. In the scavenger hunt of things to look out for, I want to at least leave you with one little nugget. There will be something here for everybody, and there may be everything here for at least one somebody. We're probably going to have what I would call chapters. You see them on the screen here. We're going to talk about secure supply chain, confidential computing, and then we're going to talk about container security, Kubernetes security. Towards the end, I've got a lot of content. I'm fond of saying we're going to stay pretty high level, but we're going to stay a little bit medium level. So we'll do a little bit of nerdiness, but there's a lot of flow going on. If you have questions or feedback, there is a handily named questions pane here. Feel free to drop questions in there. I'm able to see them sometimes, but a lot of times I'm moving on with a bit of content. If we're not able to answer your question directly in this webinar because we've either run out of time or I don't know the answer to your question, I promise we will get back to you personally because, well, we're just the swell kinds of people. So rolling on, let's make your time worthwhile here. First of all, in our first, our first sort of chapters, we're going to talk about, security, right? Well, security is about protecting what you value most, right? Your business. I mean, there's nobody who isn't a software company these days. And IKT, that's your applications, it's your infrastructure, data, whether it's your data or data of your customers, especially if you're running compliant workloads. What we're going to do is we're going to talk about how SUSE can limit your attack surface from your operating system to your applications. We want to make sure we help you ensure the confidentiality, the integrity, and the availability of your data. All three of these go together. And I'm fond of saying, because I believe that it's true, that security is actually a child of BCDR, business continuity and disaster. It's availability. Your business, your IT infrastructure can go down from any sort of violation of security in the same way your infrastructure could go down if Godzilla ate your data center, right? Down is down is down, and you're exposed. So how does SUSE help you achieve the strong security? Let's roll on with chapter 1. Let's talk about secure supply chain. You've been hearing a lot about that. An analogy, right? Look at this beautiful scene. Please try not to get distracted. That does look nice. I'll take the cabin on the right, honestly, so that I don't have people on my lawn and the picture on the left. But let's imagine you're building your dream house. And when you do, you're going to have materials, wood, nail, bricks, paint, things that make a house go together. Don't build it out of straw. These materials are not made on site. You have to get your materials from various suppliers. They bring them to the construction site, we put them together. You've got a series of steps to build your house. Stay with my house analogy here, from acquiring those raw materials to putting them together, and you build your house or your cabin. I like that boat. This series of acquiring materials and assembling them to build your house is essentially the supply chain for what you're trying to do. And very similarly, in the world of software development and deployment and running, a supply chain is the process of creating software usually by assembling lots of different components and the dependencies betwixt those components. Instead of physical materials, of course, software relies upon code that you write, you beg, borrow, or steal, libraries of code, tooling. These components quite often, depending upon who you are, that intermix come from external sources, maybe even open source materials, which we like. Just like the materials for building your house come from your supplier. And when you're building a house or you're building software, you need to make sure that your supply chain is secured and that, well, it's reliable. So in that landscape of cybersecurity threats, supply chain attacks have really emerged, I think even more in the last few years, as very powerful and very sophisticated method for breaching the defenses of organizations around the world. These attacks target that supply chain, that software supply chain. And what they're doing is exploiting vulnerabilities in trusted suppliers, or maybe not trusted suppliers, products, to infiltrate the systems of unsuspecting users. Among the supply chain attacks, and I know we're talking, it's almost 4 years ago now, but we still talk about the SolarWinds incident, because it got a lot of press and it's gigantic. Also, it's a really good example of how we can have problems if we're not sort of watching our back. The scattered global attention, and it did raise awareness about the importance of securing your software supply chain, because folks weren't listening to nerds like me. So what happened? Right, it was actually early 2020, it was 4 years ago exactly. Hackers very secretly broke into the SolarWinds systems, and they added malicious code into a system. The system was called Orion, still is called Orion. It was very widely deployed and used by people to manage IT resources, right? So it's a management console. I happen to be a big fan of it. But now that Orion was compromised, SolarWinds, without knowing so, unwittingly sent out software updates from that supply chain to all of its clients that included that hacked code. The code created a backdoor to clients' IT systems, which the hackers then used to install even more malware that helped them spy on other companies and other organizations. So the whole point here really was sensitive data exfiltration. Right? Hackers hack in for multiple reasons: fun, taking down systems out of malice, certainly crypto locking. We see stuff about this on TV every day, including the Ticketmaster thing that's just this week. But this one was really sensitive data exfiltration. And because the consequences, because of this was all very wide reaching and impacted in a lot of organizations, including major technology companies, critical infrastructure, and of utmost importance, even government agencies, we did see some light shown on that vulnerabilities can exist inside of a software supply chain, and that the potential for malicious actors to exploit that software provider to compromise an extensive work of network users. This is, on little bits. It's happening before, it's happening all the time. We want you to continue to try to secure that supply chain. And much in the same way that we at SUSE pioneered enterprise operating systems, we also pioneered the supply chain security in the open source space. First example is SUSE was the very first company to achieve what's called the Common Criteria Evaluation Assurance Level 4 Plus. We did not make that up. What that means is augmentation. SUSE is capable of handling issues inside of the system very properly. This certification, this Common Criteria 4 Plus, is given out by the German BSI Institute. If you don't know, the country of Germany is very strict about security and compliance. So that's a great place to try to achieve that kind of security. And what it does is it really certifies that the process of creating operating systems is watertight. What we're trying to do is properly vet, and we do properly vet everything that comes from the communities, making sure that, one, that the community it's coming from can be trusted, two, that the code itself can be trusted, and three, that there's code integrity. There's nothing wrong with the code. SUSE does the QA, all with change tracking that's required to make sure that the code that you are running is fully hardened and fully secured. Also, recently, the industry saw another certification come out. This is, the abbreviation is SA, LSA, or SLSA. You know, we just call it SUSE. From here on out, I'm just going to call it SUSE. The Linux Foundation rolled this out, and the moment that it came out, we at SUSE looked at that specification. We're like, hey, we could probably do this. It looks pretty easy because we were already doing things that were part of that certification spec. All we had to do is amend a few processes and we were done because, again, we had done most of the work for the common criteria. That was SUSE. This is funny. That was SUSE 0.1 when SUSE got the highest level 4 certification for SUSE. When the actual release of SUSE came out, we wound up being certified at level 3. Why level 3? Well, in 1.0, they took away level 4 because apparently it was way too hard for other organizations to achieve. So we can sort of brag, we're level 3, but we're imaginary level 4. This one goes to 11. So we've got it approved by the Linux Foundation, but nobody else was apparently able to get it. Common criteria and SUSE. And the other way to really fortify our digital house and further transform it into an impregnable fortress, we can also implement a process known as hardening. So much like reinforcing the walls and security measures of a physical house or a castle, as we may see here, hardening the operating system involves bolstering those defenses against potential threats. So one of the ways to do that, when you're reinforcing those digital walls, like in a house, walls are the first line of defense against external elements. Similarly, in our operating system, the software walls actually play a very crucial role in protecting it from unauthorized access and attacks. Hardening actually involves configuring the system to reduce the attack surface or the attack surfaces. We remove unnecessary services, make sure we apply security patches to known vulnerabilities, and just as you might secure the doors and the windows in your house to prevent further unauthorized access, that's where people come in and out, you need to secure access points in your operating system. We can mention things like password policies, of course, multi-factor authentication, and other access controls, right? We know what the RBAC is about, that act as sturdy locks and barriers to keep those intruders out. And in a well-secured house, the third point here, you maintain visibility, right? We need to monitor. We install things like lights and maybe surveillance cameras to detect those intruders. That's monitoring. I've got a Ring security system in my house. It's called Ring Security. I like to call it Ring Monitoring. It doesn't really secure my house. All it does is give me a nice clear 1080p view of somebody stealing my TV, but you put it all together, and once you've configured system logging and auditing, now you're able to monitor activities that might be outside of the normal scope of operations inside of your environment, spot things like anomalous behavior, anomalies in themselves, and trace those potential security breaches. Those are really some examples of what can be used to apply to a system. So to summarize, back to our house or our castle or that cabin in the woods, the one that's my favorite, with SUSE Linux Enterprise, or SLES as we call it, you actually get the highest level of supply chain security, meaning that the contractors, the suppliers can be trusted, and that you're using, well, high quality materials with, this is important, regular inspection, regular maintenance to build your dream house, your dream castle cabinet. And if that's not enough, you can reinforce its security by applying it automatically or not, it's your choice, additional hardening. There are lots of choices inside of that environment. That's secure supply chain. Chapter 2, let's talk about confidential computing. Now, this one actually gets kind of fun, and I've got a little live-ish demo I want to show you, so you can watch the nerd trip. If we talk about confidential computing, right, there are a couple, and what we're talking about really is kind of data protection at this point. There, of course, there's data in transit. Very obvious what that is, making sure that your data isn't stolen, intercepted, or modified, right, man-in-the-middle attacks, while it's moving across your network or some other network. Technologies like SSH or SSL, TLS, encrypting things are certainly part of that. The other thing we're going to look at later on came a data at rest. And this is what that name sounds like too. Data at rest is when you do things like, dispose of, drill your hard disks, or when it gets stolen, you don't want your data to be exposed, so you do encryption at your data at rest. Most of us are doing that, or generally being required to do that inside of your environment. And these are kind of table stakes, right? Every major operating system has technology to do data at rest and work on data in transit. My laptop is encrypted data at rest. Well, one of the things that kind of was missing or is coming into play now was in confidential computing. And what confidential computing does is protecting your data in use. So without confidential computing, if you want to actually do computation, having computers do computing stuff, your data has to be loaded into memory from the disk, from the network, wherever your data comes from. And when you load an application and data into memory, it has to be decrypted, right? So that it can be worked upon, be used. And it lives in the main memory of your computer, unencrypted and accessible, of course, to that computer. Of course, an operator on that very same machine could probably spy on your data when you process it, and could potentially see and exfiltrate your data, do all the bad things we want to do with data. And that really becomes a problem when we start to move things to shared resources. That hole in data security that confidential computing is closing keeps your data secure while it is also in use. So these things are certainly objectives. Encrypt it here, protect it, protect it, protect it. So let's, if you're wondering, you go into an office, or wonder about the level of security in, say, a shared workspace, thinking about, physical people in an office. Are the USB ports locked down, vulnerable to hacking? Does somebody belong in this building? Is the network safe? Can you trust the person sitting next to you? The key challenge in a multi-tenant environment, like multi-tenant compute, even if it's private or public cloud, is sort of a lack of trust. And that's why we're really motivated to do confidential computing, especially, again, when I'm thinking about protecting data in use. So here's an example, right? In a public cloud environment, when you consume public cloud compute in various forms, you as the end user, me too, we don't really have any control over the hypervisor that's running the VMs that we're paying for, or the machines that are sitting underneath it. In fact, this is shared infrastructure. That's kind of the point of the cloud. You have no control over what's happening here, visibility, and certainly security. So what confidential computing is doing is focusing on ensuring that the virtual machines running in this multi-tenant environment, like this is us, this is our computer, and it's some other people over here. We want to make sure that those virtual machines can maintain the confidentiality of their data during runtime in use. Good news is, in last several years, the CPU vendors have actually started to integrate features which allow all of us to set up isolated and trusted execution environments that's actually inaccessible from our neighbors in this infrastructure. So, for example, AMD has got their SEV, their SEV-ES, their SEV SNP. In fact, in a moment here, I'm going to show you that in work. Intel, their SGX, TDX, IBM's got their secure execution, for example. So where does SUSE fit in all of this? Where SUSE adds value is a couple places. We have a complete software stack that's cryptographically signed, including all the way across the BIOS, the hypervisor, the bootloader, and the operating system. We also have remote measurement and attestation, so that you can verify the integrity of what's running in a remote system if you're using SUSE Linux Enterprise or SLES. SLES is also supported for confidential virtual machines, of course, on almost all of the public clouds, or I actually can't think of one where we're not. And we participate very actively in what's called the Confidential Compute Consortium. We're working on an active development right now. You could go to our website and see where we're at with it. We've initiated what's called Coconut SVSM. That's actually a software project working to provide TPM to confidential VMs for remote attestation and key storage. And like it sounds, it's able to go, hey, is this, is the integrity of this operating system still real, right? It's a rather complicated key signing measure that makes sure we understand what's going on inside of our environment. So emerging, from all the essential characteristics, customers deploy confidential computing. You deploy confidential computing in really three major types, and it depends upon the outcomes that you're seeking. One of them is, of course, data security and IP protection. So there are projects that prioritize straight up security and value how confidential computing can protect the application and the data from very classic attack vectors like malware, hackers, tampering, and of course, data theft, exfiltration. These projects are usually designing specifically very much for security. If we look at privacy and compliance, there are other projects inside of this umbrella, confidential computing, that prioritize the availability of the confidential computing platform so that you can perform complex analysis on private or regulated data, that's you, while keeping it protected and out of the view of unauthorized parties. It also helps us activate this data and derive value from it while remaining compliant for workloads like GDPR, HIPAA. China has PIPA, PCI DSS. These can be single-party apps, but they're usually multi-party, so that where sensitive data is contributed to a mutually beneficial analysis. And then third, the data sovereignty and control. The big motivation in this third box is inspired by the growing data sovereignty movement. And this is where data is viewed as critical to an organization or a national asset. It's a little bit more about location. So multinational companies, also cloud providers, are likely very much subjected to multiple data governance regulations and legal frameworks. But cloud tenants, if you're in a cloud, you may want your data governed under a specific framework, let's say GDPR for the UK. So what confidential computing creates is a technological separation between the workload and the data and the cloud provider, and puts in encryption keys so that the data in use is in the hands of the owner, not the provider. We'll say that again. So what we're doing here is we want to make sure that you've got the keys, the cloud provider doesn't have the keys to your data. And so that this separation and control, a separation of church and state here from the cloud data, adds another layer of technological safeguards to an organization so that you can have data sovereignty or geolocation programs. For example, if you're a US company, you want to make sure that your data is actually sitting inside of US shores for data sovereignty. And we've sort of seen this, right, in a study of demand for confidential compute. 75% of that demand was actually driven by regulated sectors, right? With regulations really pushing this. Fintech, banking, insurance, healthcare, of course. Public sector and defense naturally are being motivated by the compliance and confidential computing, and even life sciences. Healthcare is leveraging AI, for example, and expert systems, and they've actually got real patient data there, right? So there's a huge amount of processing power in the cloud, but one of the problems with healthcare is being able to use the cloud wasn't really an option due to those regulations. Patient data needs to remain confidential, and the integrators and providers were really struggling to manage this data outside of the organization. Confidential computing helps with that. Same with financial data, right? Bank transactions need to be encrypted, public sector, and even telcos. They've got a huge amount of data. What we're trying to do is kind of unlock the cloud for other organizations. So this is now, live demo time or semi-live demo time. I actually recorded this because, I didn't want to tempt the demo gods with two gigantic demos. Take a sip of my tasty beverage here. So I want to show you a little bit about what this confidential computing looks like when we're doing that thing to protect the data in RAM. So if we're going logged into a terminal here, I'm in a VM and looking at, this is actually SLES version 15, Service Pack 4. Here it is, right? So I can show you what this what this compute is. We certainly have a encrypted hard drive here. So we've got encryption, data at rest. We're even doing encryption. We're protecting data in transit. And you can see right there, on the hard disk, we've encrypted it. We're taking care of that there. So what I'm going to do is let's have a little fun. So we're going to make a secrets text file, put a little password in here. Let's see, our password could be my secret password and a bunch of gobbledygook. There's my password. I'm going to save this text file, put it down to disk inside of this VM. So now what I want to do is switch over. This is the hypervisor. Right? So the hypervisor is that underlying infrastructure that hosts the VM, makes it run. And I can go into the hypervisor. Let's go take a look. How many VMs are we running? There's my one, right? There's the SLAS 15. That was the VM we were just in. What I can do here is actually go look at that. I've got that document that was sitting inside of here. And what I'm going to do is I'm actually going to use, this is a very publicly available tool. This is called readmem. Guess what it does? It reads things out of memory. So this is a commonly used hypervisor. I'm going to take this readmem and I'm going to use it to go look inside of my VM. So what I'm doing here is I'm actually just grepping to see where are my VMs. So there it is right there. There's the VM we were just looking at. And what's its process ID? 2969. So taking that information, what I'm going to do is use that readmem utility, and I'm going to use it to look for this string, secret password. Type it in, away we go. There it is. Kind of scary, right? And now you may be thinking, okay, well, that was an unencrypted text file, Jorn. Of course somebody could read it. Fine, let's go read an SSH key. Bam. So we were able to read this data out of a running VM in a fairly recent version of SLES just right up from our hypervisor. So let's try this again, a better way. This demo will go exactly the way you think it's going to go. I'm going to log into another VM, but this time, this VM is, I've got a secure operating system, but what I'm doing is running a version that has the AMD SEV-ES, that stands for Secure Encrypted Virtualization, encrypted state. So just running on that infrastructure using a version of SLES that supports it. Otherwise, same thing, right? We're going to take a text file, going to create my secret password of gobbledygook, save the file, run it in the same way. You know what's coming. I'm going to list my VMs. There it is. I'm going to look for it, found it, going to find the process ID, and we're going to use readmem again. Secret password. And hey, look at that. Nothing's happening. It didn't work. Now, the great thing about this particular story, we'll try the SSH too, is it's not that it's just exciting that it works, but the fact is, the fact is that when we get done here, confidential computing is involving data in use. So you can secure that data like you just saw in my little demo. And what this actually does is, like I said earlier, it unlocks the cloud, right? Before confidential compute, you really wouldn't want to put protected infrastructure, compliant data use in the cloud. Now you kind of can, because you've got a trusted service provider. We are attesting that the main public cloud providers supporting all the confidential compute technologies helps accelerate those migrations. We're able to third-party attest that it's still the way it's supposed to be. And I think this is one of the most important parts, is that it's transparent for the customer. That's you. You don't need to do weird things like changing your entire workload or changing your code. You deploy a confidential compute supported version of something like SLES onto infrastructure that supports it, and you move on with your life. It's the same way. And SUSE is co-innovating with vendors. We're always working with other vendors to offer protection outside and inside from the attacks. For example, SUSE and AMD, like you just saw. We have a long history of upstream collaboration across all sorts of key AMD initiatives, including confidential computing. Like we started doing secure encrypted virtualization way back in 2016. And we followed that with the encrypted state SEV, that's SEV-ES, and the nested paging, which you actually just saw a demo of. So again, very, very easy to get this in place. It's sort of a, why wouldn't you choose this? All right, chapter 3 of 3. If you've hung on this far, I appreciate you, and I want to get some value out of it. We're going to talk about container security, Kubernetes security. There was a recent actually survey. This one's from 2022. I should probably paste the 2023 one in here, which looked about the same. That CNCF, if you don't know, CNCF stands for the Cloud Native Computing Foundation. That's where a lot of those open source initiatives live, including Kubernetes. They found that security was the top challenge for organizations containerizing their workloads. And they also cited that lack of training was a top challenge for adopting containerized workloads. So what that tells us is we really need solutions that people can use so you can have a stress-free experience right out of the box. And so one of the challenges, one of the things that kind of makes working in containerized environments a bit of a challenge. And from here on out, I'm just going to use the word Kubernetes as a pronoun. That's the most common way people are doing containerizations. And when I say Kubernetes, that can be anything from, EKS or GKE, AKS and the cloud providers. It could be OpenShift, Kubernetes the hard way, K3S, or most certainly Rancher makes everything a lot easier to run a Kubernetes environment. But generally speaking, one of the big challenges you have with doing security inside of a Kubernetes environment is certainly the sprawl of containers. And if you thought, that managing a bunch of VMs coming and going from everybody that has access inside of your environment is challenging, containerization makes it even more challenging. The thing about containers or pods in the Kubernetes environment is they're really kind of two things. One of them is they're ephemeral. They come and they go. Even parts of the infrastructure can come and go. So it's very challenging to say, secure this thing or that thing. The other challenge, and depends upon what glasses you're wearing today, if I'm a developer and I'm like, wow, networking is hard and I've got other things to do with my life. The good news is the network inside of a Kubernetes cluster is flat and generally mysterious, and everybody can talk to everybody. And if I want my applications to work, I'm like, wow, that is great. If I'm a networking or security person, I'm looking at a network that's absolutely flat and we're all friends here behind the firewall and I also can't see the network. That's terrifying. I want to, now we've sort of rolled back security. So what we're trying to do inside of this environment is, from a goal standpoint, is shrink that security boundary down to each and every workload rather than we're all friends behind the firewall kind of approach. And what we're reaching for here, and what I want you, one of the things I hope you get out of this talk today, is I really want you to want zero trust as default. I'm gonna mention zero trust multiple times today. The very simplest and most direct way to describe zero trust is that zero trust means the implicit state of any environment is to not trust something until we explicitly do. Great analogy for that would be the security lines, the TSA lines at the airport. That is a zero trust environment. Implicitly, by default, nobody is allowed into the airport unless they explicitly are. Do you have a boarding pass? Let me see your passport. That's different than, say, a no-fly list. A no-fly list is not a zero trust control. It's actually a threat-based control. We have a list of threats we would not want in there. Security is very much in your infrastructure is very much the same way. What should you do? You should do both, but do not do just one. Do not just result in you thinking that patching my software and looking for threats is true security. I will just tell you, it's not. So from our goal standpoint, we want to be able to bring back, because this is a traditional level of security, zero trust controls and visibility to an environment that we've been doing this kind of stuff for 30 years from a security standpoint. The container environments kind of broke it. We're trying to bring it back. So we would like to introduce to you NeuVector by SUSE. NeuVector is a company that was acquired by SUSE about 2.5 years ago. Many years ago, the founders of NeuVector saw that state of, wow, the network is flat inside of the environment. and set forth to fix it. And I'll show you what that's like in just a moment, both with examples and with an actual live demo. But NeuVector brings you sort of 8 distinct security layers or practices. You don't often hear about vendors talking in terms of layers of security. I want you to care about layers of security. Even if you're perfect at one, hackers find a way to get around them. If we start out, the first 2 layers that you'll see here are extremely familiar. Almost feels like table stakes. One's vulnerability scanning, the other one is CIS, security config scanning. Both of these will fall under the auspices of that verb scanning, right? We are scanning for CVEs, common vulnerabilities and exploits inside of the environment, things that need to be patched. And we're scanning for things like CIS config, looking at the configuration of your images, and in your cluster, report on the differences between your settings and those recommended by the CIS benchmarks and other best practices. We do the same thing, not only from a supply chain standpoint, we just got done talking about supply chain, but also at runtime, things that are already running in your environment, checking for CVEs, checking for CIS scanning, and other benchmarks against your environment. The other thing that NeuVector brings you, and this is very common inside of Kubernetes, is a powerful layer. I would call it the sort of the third one, is right at the edge of your Kubernetes cluster, right at sort of day one, and that's admission control. There are really kind of 4 important points to highlight why NeuVector by SUSE's admission control is really one of the more popular layers. One of them is that NeuVector's admission control is Kubernetes native. It uses the Kubernetes built-in admission controller. Yeah, you could still continue to use PSAs, pod security admission policies that you're already using, but NeuVector can actually complement or even replace those admission controls with a tool that's not only more powerful, but easy to use, because point number 2, you can pick and choose from a minimum of 31 built-in policies. There's no coding required. You don't need to know YAML or Rego. You just point and click and go, hey, this is one I want to protect from. I want to say I don't want any high SEV CVEs in my entire environment, or I don't want people deploying workloads from an image that comes from a non-trusted supply chain. The answer is no to that. And we can also, inside of NeuVector, there are modes in there to either test your security, alert that a violation went on, or enforce it, and I'll show you a little bit of that. And the other wonderful thing about that, not only from admission control, but other parts of security, is that we can codify the security and use it to template across multiple environments. Those are supply chain characters. If you go look now, here's the thing that makes NeuVector actually very special and unique, and that is first, layer number 4 here, or item number 4. NeuVector's network security policies are one of 2 zero trust focused security layers. Remember, we're talking about threat-based controls and zero trust controls layering inside of here. NeuVector is actually the only security platform, open source or otherwise, that automatically creates layer 7 network security policies. And it does so by inspecting actual live network traffic. NeuVector is also doing deep packet inspection, so other network policies are extremely accurate, and we can support, again, both that alerting or the enforcement inside of the environment. NeuVector also supports process and file security policies, just like the network. These are also zero trust controls. Again, in both of these, what we're trying to do is establish a pattern of what's appropriate inside of the environment, explicitly define it, and then use the implicit deny policy to make sure that things that don't belong in our environment don't actually happen inside of our environment. There's also network threat detection, and I want to caution people, don't confuse these 2 or conflate them. These, layers 4 and 5 here, from a network and a process standpoint, what we're doing again is establishing zero trust controls, but because NeuVector's got its own sole source of truth about what's actually happening kind of on the wire inside of Kubernetes environment, we're also able to take a list of actual threats, use a threat-based policy. Hey, we've detected this on the wire. It looks like this might be a SQL injection attack. Those have particular patterns. As should come as no shock, you can either alert that it's happening or alert and actually stop it. And then layers 7 and 8 are using actual deep packet inspection to do things like either ingress WAF sensors, so it's looking at the payload, or data loss prevention. If you're hearing my voice right now and you're under the cloud of needing to pass particular audits for compliance, whether it's say for example HIPAA or PCI DSS or even SOC 2, one thing that all of those have in common is your auditors are going to ask you, do you have network microsegmentation on your workloads that says, these compliant workloads can only talk to each other and non-compliant workloads can't talk to them? The answer is yes. It's right here. And your auditor will probably ask you, if they haven't already, what are you doing about data loss prevention or data leak prevention? How are you making sure that compliant workloads aren't being stolen from your environment? So for example, maybe say a credit card. Because NeuVector can help you inspect that packet, you can set up rules that say, hey, this looks like an American credit card or a social security number. We can alert or block the exfiltration of that data from leaving the workloads that are compliant with that data. I think that the proof is absolutely in the pudding. And if you'll allow me, I'm going to try to do a very quick demo. Even as fast as I talk, I realize I'm already gobbling up your generosity of giving me an entire hour here. So what I'm going to do, I drew a little picture here. I'm not an artist. I want to show you security, zero trust security, the way it might work in the real world, right? I want to meet you where you are. I would imagine that you test your software before you deploy it. And if that's not true, just nod and say, yes, of course we test our software. We don't test in prod. There are probably at least 2, if not 3 phases that any software can be in your SDLC, and you run right back through it. One is going to be a dev test. On the far right here in my diagram will be production. We've deployed production and maybe a QA cluster. So we're going to test our software. We're going to test the tests to make sure that we know what we're doing, and then we can issue it off to production. So what I'm going to do is I'm actually going to use NeuVector to keep an eye on that, and we're going to try to do a live demo. So let me pop on over to my console here. I'm actually in a cluster with NeuVector installed in it. My password logged out. Let's log back in. So this is NeuVector. It's sitting on my little cluster, SUSE Exchange, dev test. I have another one installed in my QA cluster and another one installed in my pretend production cluster. So what I'm going to do is I'm going to do, some version of what you probably do. Let me show you a place. I'm going to go right inside of the interface. I like to say that this is where work gets done. Remember when I was talking just a few moments ago about how it's really hard to bolt down how to secure items inside of your environment, because it's really hard to bolt those items down. I can't say it's this IP address over here or that network block over there, or it's a workload running on a particular node or VM on the underside of my infrastructure. You have to have a way to say, hey, this is this workload. And then we're going to learn things about that workload and then use what we've learned to secure the workload with explicit allow policies. That is the pattern here. That is the best practice. And you'll see inside of policy and groups, NeuVector actually creates these groups for every workload that's sitting inside of your environment. So stay with me here. What I'm going to do is I'm going to actually just deploy an application to this infrastructure. Let me clear that out and show you what I'm about to do. So I'm on my dev test cluster. You can see my context here, or take my word for it. I tend to abbreviate some of these commands. So what I'm going to do is I'm just going to deploy an application to this workload. This is a test app. It's widely available. It's a pretend application, but it's got multiple pods and containers to it, because it is a multi-factor app. It's got front ends and back ends. It creates a nice pretend shopping cart. And I'm even gonna go see if I can list that deployment. So here it is, it's starting to deploy. While that's going on, I want to explain to you what it is you're about to see inside of this environment. So any given group, not just the entire cluster, but any group, any given workload in NeuVector can be in one of 3 states. The first state is discover. Thankfully, it's a very clear use of an English word. What's happening in NuVector, and this is the default state in the environment, is what's called discover mode. And it really is discovering. It's discovering all of the processes that run on any container inside of a pod. And it's also discovering not only the network connections, but the network connections all the way up to layer 7. It might be a reminder for a lot of you, but remember the OSI model, the networking model, has 7 layers, all the way from 1, which is the physical layer, all the way up through layer 7. And the layer 7 is where the application is actually declared. You'll find a lot of supposed security or networking tools really stop at layer 3 and 4. Well, 3 is just the protocol. Of course, it's TCP inside of this, or IP inside of this environment. And layer 4 is just declaring the port that it's on. For example, DNS happens to use port 53, but that's because it's behaving itself. We don't want to just trust things that they're using the right port, because we probably don't believe that the internet is totally honest. The thing about Discover is it's mapping out the appropriate behavior of your application and establishing what might be that fingerprint of the appropriate behavior of that application. And you then, depending on what you're doing in your life, could switch it over to what's called monitor mode. Now, monitor mode stops learning. And it's going to take what we learned in Discover. And yes, by the way, you can manually add these rules of behavior, manually delete them if you like. And it's going to alert you, hey, this connection happened, this process ran, and it's not part of my explicit allow list. Attention, human being, what do you want to do about this? Not only will that alert happen in NuVector, it'll be sent off to your SIEM, Datadog, Splunk, Prometheus, whatever it may be, which we believe is a best practice. But what Monitor is not doing is actually enforcing those rules. It's just telling you that the rule happened to be violated. The primary reason we invented monitor mode was to do a dry run up against what's called protect mode. And you, congratulations, I know you've guessed what's happening in protect mode. Protect mode is much like monitor. It's going to tell you something attempted to violate the rules, but we stopped it. We stopped the process from running. We stopped that network connection from even being initiated on the wire. This is not a whoops, something's going on, and then a few moments later, maybe we should do something about it. This is actual true protection on the wire. And if you don't mind, I'll see if I can show you how that's running in real life. So actually, the moment that I deployed this application, if I go back to my cluster right here with NuVector in it, I'm going to sort by namespace to make sure we know what's going on. You will see this online boutique namespace. There are all my workloads. These groups were created, again, instantly, automatically, when this environment is deployed. So for example, if I click on the front end, and let me zoom in so that you don't have to squint like I am, there's very straightforward information about it. For example, right? We have a member of this group. There is the server pod, that front end container. That's this container, right here. And NuVector could see that it exists. If this container needs to be scaled to 2 or 3 or 10 or gets a rolling update, it will always be a member of this group. And that's what's important. The process profile rules are just that. These are processes that have run on the container while NuVector was watching, which happened while I was going blah, blah, blah and talking to you, and even some network rules. So you'll see here right away, these things were discovered. The front end talked to DNS to do some DNS lookups. The front end talked to the currency server. So all of these stacks, these pods for this whole application stack are talking to each other. In fact, here, let me show you something really neat while we have time. So I'm going to grab the name of this container right here. And what I'm going to do is I'm going to kubectl exec, and I'm talking out loud while I type. I'm going to shell into that container. So I'm logging into the running container for the front end service. There I am. In fact, if I go back and refresh this right here, you'll see, look at that. SH showed up because I just did it. I could do a who am I, or list the contents of this directory, or I could even do, let's go wget SUSE.com. Running things on this container, guess what? It shows up as things that happened. Even let's take a couple seconds to see if that wget shows up. There's wget, right? I downloaded a website. Now, what I could do in here is say, wow, I don't want wget. I don't want people running that. So I could actually manually go in here and just get rid of it, right? I'm going to delete that rule. What I'm also going to do is I'm going to take this group and I'm going to switch it and put it into monitor mode. Now remember, monitor mode doesn't learn things. It only monitors for violations of the rule. So here we are, front end boutique is in monitor mode. I'm back here talking, I'm shelled into my container. Let's try running wget SUSE.com again. Hey, it worked just like last time. Why did it work, class? Well, because we are only in monitor mode. We're looking for violations, not actually enforcing the rules. If I go to my log, I can go see from a security event standpoint, poof, there it is. This is something that happened, right? So for example, it could be as its originally intended use, a dry run to make sure that you've got all your rules in place. But the other thing, a wonderful byproduct that users like you really helped inform us when we were developing and continuing to develop this platform, is that this is actually extremely valuable information. Even if you weren't in protect mode, you now have deep insight into the behavior of your application, your Kubernetes environment that you didn't have before. And you could get this kind of information about your environment in a matter of moments, and I'm not even joking. It's very easy to install. It's innocuous to get it inside of your environment. But if I go back to policy and groups, let's go find my front end real quick here. Let's go my front end. I'm going to take this and I'm going to switch it into protect mode. Okay. Yes. Now we're in protect. Remember, wget is not in my list of allowed things. And from a security standpoint, if it's not in the list, it's denied. See, it's a lot easier to have a short list of good things than a list of a bajillion things that are being denied, especially if you can't keep that list put together. Let's try this again. Doesn't work. One thing I want to point out here is I'm shelled into this container. I am root on this container. I attempted to run this process and NuVector automatically killed it. If I go back to my notifications, look at my security events, you'll see there it is again. Now, this is real life, right? We make mistakes like, oh boy, you know what? I really want people to be able to run wget. You do not have to go back to discover mode to wait for it to happen to relearn that process. I could just add it as a rule right here. Go back to my policy, my groups. Let me filter down to front end. And if we go on my process profile rules, you'll see wget is back in here. I just added it by doing a user created rule. Similarly, on the network standpoint, I could go find the activity that made that happen. Where's my front end? Talking to the outside world. Here's the rule that was learned. Again, every time something happens, we learn it as good. I could go delete this rule. So that's front end talking to the outside world. I'm going to save it. Yes. I'm going to save it again. So now it's no longer in the list. Remember, I'm not explicitly denying things. I'm implicitly allowing them. Well, I took away that implicit allow rule. Let's see if I did this right. I'm going to try wget again. So remember, I have added the process as being allowed. So it ran. Wget just ran. Now notice nothing's happening. The reason it's not happening is NuVector blocked this on the wire inside of the Kubernetes cluster. Eventually this will time out and break and it'll be very, very sad and won't work anymore. So I'm just going to control C out of that and then exit out of this container. So let's say we've been in here, we've learned all of the behavior of what our group needs to be. Here's where the fun comes in. At least it's fun for me, but I'm a nerd. I've got this is my dev test. Let's say I want to go over to my QA cluster. I'll bet you I need to log in again. Yes, I do, because I haven't looked at it for a couple of hours. Here it is. There's the groups. Very boring infrastructure here. If I go over to this place where I'm testing my environment, I could take this rule, or you know what? Let's grab every single one of these because it's part of my namespace. This is part of my online shopping cart. In fact, I'll even show you what this looks like. There's the application that I'm running. So I might swizzle my app, buy sunglasses for everybody, add to cart. That's the app that's running in my environment. I do want it to work. So I'm going to grab all these groups. And what we're going to do is we're going to take this and export the group policy. So I've got this drop down here. And what this is doing is giving me the opportunity, and we can do this with an API call, to make an assertion in the file that the export you're just about to see, whether I want to leave the groups in the mode that they're in, or if I want to, in the export, assert that they're in a particular mode. I'm going to go over to my dev test cluster where I'm going to test all my rules just like I'm doing with my software anyway. So this is almost zero added work, honestly. I'm going to export this as monitor mode. We could also send this off to GitHub if we really, really wanted to. I'm going to allow that. I'm going to put this in my NV demo. Here we go. And then what I'm going to do is I'm going to go open that document up. I got to go find it now on my computer. There we go. There it is. So the file I just exported is YAML. It's a CRD file. Custom resource definition allows us to expand the way Kubernetes works. This is a text-based manifest of all of the behavior of my application. Wonderful. We could look at it and go, yes, this is the way my application behaves. If I'm in the security or compliance department, I could take this, show it to my application owners and go, is this the appropriate behavior of your application? Yes, great. No, edit the file, do what you need to do. Because the real magic comes when I go look at this cluster here, and then I'm gonna go change my Kubernetes context. I'm gonna go point at my QA cluster. There it is right there. My online boutique, I need a place for this to land. Did I spell boutique right? Realize that the word boutique is actually challenging. Oh, it already exists. So what I'm gonna do is I'm gonna just take that file, and that was started with G, with 2024. What was the name of my file again, folks? What's the date today? There. All I'm doing is spraying this file at this cluster just using that kubectl apply command. You could put this into a Helm chart, you could put it into a CI/CD tool. Whatever I'm doing is I'm shipping the code about the way my application behaves with the code of that application, or doing it as a different swim lane like I just did here. If I refresh it, I'll sort by namespace, you'll notice there are my security rules, all the things that I learned about this from my dev test cluster. My security rules are in place before my application even lands. These are enforced before they actually get there. And I'm able to codify security and put zero trust controls in, actually in a matter of moments inside of my environment. And the good news is that all of this is actually open source, just like everything is that we do at SUSE. So kind of as a summary, if we look at threat signature and zero trust controls, and I'm talking fast because I want to respect your time, there are two different things. If you get anything out of this, please remember there are multiple places to do security inside of your environment. SUSE's got the chops and the ability to give a lot more from a security perspective. There's a lot of technologies from operating system, virtualization, containers, and Kubernetes like you just saw, and even developer tools. We're trying to do the work so that you don't have to inside of your environment. So if you take anything from this, we want to limit your attack surface from your OS all the way through with confidentiality, integrity, and keeping your applications up and running. My parting comment as we have to go to wrap up our environment today, because I spent too much time talking, is I want to make sure that so that you're entered to win, and I will put this in the chat, the URLs that are up on the screen right now. Please be sure to attend part 2 and part 3 of this series. On the 26th, the Modernize Your Business, and on July 10th, Accelerate Your Business. If you're not able to scan those now or get them in the chat where I just sent them to you, I know Jamie will remind you what's happening inside of this environment. If you have any other questions that you want to put in the QA, please do so. We'll try to get back to you very, very personally. But until then, I do really sincerely want to thank you for joining us today. I hope you got something out of this. Like I said, you're paying to be here. We want to get value out of it, and we will see you on the next SUSE Exchange webinar. Thanks.